Welcome to our deep dive on the tech behind asteroid mining. Seems like you've already done some research on this, which is
Yeah.
fantastic because we're about to dig even deeper.
Mm.
What's really cool is that this isn't just science fiction anymore. We're
Right.
talking like real world technology that could change the future of space exploration.
Yeah, it's a pretty exciting field.
Yeah.
For sure, your sources highlight some of the key areas,
Yeah,
robotics, ISRU, this is using what's already out there on the asteroids,
right.
and of course, how to do all of this as efficiently as possible.
Right. We've got to optimize those missions,
Yeah.
especially when you think about, the distances involved and all the challenges. But first, let's talk robots.
Hmm.
I have to admit, the idea of robots working completely autonomously on asteroids, millions of miles away, is mind-boggling to me.
It's a huge leap.
It is.
From what we've seen with rovers trundling around on Mars,
Right.
the environment on an asteroid is completely different.
Yeah.
Microgravity, you've got these extreme temperature swings, and then the potential for unexpected events,
Oh, yeah,
like
yeah.
meteoroid impacts. So these robots need to be incredibly resilient and adaptable.
It's almost like we're asking them to think for themselves.
Right.
Your sources mentioned there are three main types of robots that are going to be involved in this.
Exactly.
Yeah.
First, you've got your exploration and prospecting robots. So these are like the scouts.
Okay.
They're equipped with an array of sensors,
Mm-hmm.
like spectrometers, LiDAR. They're mapping the asteroid,
Okay.
analyzing its composition,
Mm-hmm.
identifying the areas that are rich in valuable resources.
So they're not just like randomly digging around.
Right.
They're using serious tech to pinpoint the good stuff.
Absolutely.
Yeah.
And then you've got the excavation and material handling robots.
Okay.
These are like the muscle,
The brawn.
the brawn of the operation. So these are the ones with the specialized tools, for cutting, drilling, and moving material in that really tricky microgravity environment.
Yeah.
So think, robotic arms with plasma cutters, grinding wheels,
Uh-huh.
maybe even systems for melting and shaping materials right there in place.
Oh, wow. It sounds like a very delicate dance between brute force and very fine precision engineering.
Yeah.
I imagine keeping those robots stable while they're working is a challenge in itself.
It is, yeah. They're going to need advanced anchoring systems,
Mm.
maybe even utilizing magnetic fields or grappling mechanisms to stay put.
Right.
And then we have the autonomous swarm robots.
Ah, yes. The team players. I was especially fascinated by this concept.
Yeah. Imagine a network of small, interconnected robots,
Okay.
each with its own specialized function,
Mm-hmm.
working together like a colony of ants.
Yeah.
They communicate and they coordinate, they adapt to changing conditions, all without direct human control.
So it's not just one super robot doing everything, it's a team effort.
Right.
Leveraging the power of distributed intelligence.
Precisely. And the algorithms behind this are so complex. We're talking AI systems that allow the robots to learn from each other, share information about the environment,
Mm-hmm.
and even develop new strategies as they encounter challenges.
So for a did you know moment,
Okay.
did you know that some researchers are exploring the use of bio-inspired robots for asteroid mining?
Oh, wow.
I came across a study about robots modeled after spiders.
Really? Yeah.
Yeah, that are designed to navigate the complex terrain of asteroids using their multiple legs and like these silk-like tethers.
That's fascinating.
It is.
It really speaks to the ingenuity
Yeah.
and creativity driving this field.
Right. But before we get too carried away with our space biters,
Right.
let's ground this a little bit in reality.
Yeah.
Your research mentions some real-world examples
Yeah.
that are paving the way for this kind of a robotic autonomy,
Exactly.
right? Like NASA's Asteroid robots on the International Space Station.
Mm.
These free-flying robots are already showcasing autonomous navigation and task execution in microgravity.
So they're like the test pilots for future asteroid robots, helping us to refine the algorithms and systems that are going to be so crucial for operating in deep space.
Right. And we can't forget about ESA's mascot lander,
Yeah.
which hopped around on asteroid Ryugu,
Yeah.
collecting valuable data,
Mhm.
demonstrates how robots can maneuver and operate on these small, low-gravity bodies.
Its mascot was a huge success.
Yeah.
Provided valuable insights into the challenges and possibilities of asteroid exploration.
Mm.
But there's another company that you included in your research
Right.
that's taking a completely different approach.
Transastra.
Transastra, with their worker bee robots,
Yeah.
designed for optical mining.
Yes.
This is where it gets really futuristic.
Absolutely. Optical mining uses concentrated sunlight
Okay.
to extract resources from asteroids. So instead of drilling or digging, They essentially vaporize the surface to release valuable materials.
It's like a giant solar-powered oven in space.
Exactly.
And these worker bee robots would be responsible for directing that sunlight and
Right.
then collecting the vaporized material.
Yes.
Yes, exactly. It's a very different approach to traditional mining techniques.
It is.
And it could be especially useful for extracting volatile compounds,
Mm-hmm.
like water ice, which can be easily vaporized and collected.
It's incredibly ingenious.
Yeah.
But even with the coolest robots in the solar system,
Right.
you can't get very far without fuel, right? And that brings us to our next big topic, ISRU, living off the land, but in space.
This is where the real game changer lies.
Yeah.
ISRU is all about utilizing the resources that are already present on asteroids
Right.
to sustain our missions and to reduce our reliance on Earth.
Mm-hmm.
Imagine a future where we're not hauling tons of fuel and supplies from Earth,
Right.
but instead we're creating them directly in space.
It makes so much sense.
Yeah.
Especially when you think about, the cost
Yeah.
and the complexity of launching everything from Earth.
Mm-hmm.
But let's break this down. How exactly does ISRU work in the context of asteroid mining?
Well, it all starts with identifying the resources that are available on a particular asteroid.
Okay.
We're talking about water ice, silicates,
Mm-hmm.
even potentially rare earth elements.
Yeah.
And each of these resources requires different extraction and processing techniques.
So it's not a one-size-fits-all approach.
Right.
We need to tailor our ISRU strategies to the specific asteroid that we're targeting.
Exactly. Think of it like this.
Okay.
If an asteroid is rich in water ice, we might use microwave heating to extract it.
Okay.
Then we can use electrolysis to split the water into hydrogen and oxygen and create rocket propellant right there in space.
It's like setting up a space gas station.
Yeah.
And I remember reading about a company called Deep Space Industries that's focusing on just that,
Yeah.
developing water extraction and utilization systems for asteroids.
They are one of the pioneers in this field, and their work is paving the way for a future where we can refuel our spacecraft in deep space,
Wow.
which opens up vast new possibilities for exploration. But fuel isn't the only thing we can create with ISRU.
Right. We can also use those asteroid resources to build structures, manufacture tools, even potentially create life support systems.
Absolutely.
Yeah.
Imagine using 3D printing to fabricate habitats from asteroid regolith,
Wow.
or refining metals to create solar panels or other essential components. The possibilities are really remarkable.
And just to add another, did you know?
Yeah.
Some researchers believe that we could even use asteroid materials to create radiation shielding for spacecraft and habitats.
Wow.
Certain asteroids contain high concentrations of hydrogen, which is incredibly effective at absorbing harmful cosmic rays.
That's a crucial consideration for long-duration space missions,
It is.
especially if we're talking about sending humans beyond Earth orbit.
Right.
But to make all of this work,
Yeah.
we need to think strategically about how we design our missions, right?
For the plan.
We can't just wing it when we're millions of miles from home.
No, we can't.
Welcome back to our deep dive into asteroid mining tech. Last time we were talking about, the robot workforce and the concept of living off the land in space with ISRU
Right.
and how crucial mission planning is when you're talking about, ventures this complex.
Right. I'm still reeling from those robots, Spider.
Yeah.
But you're right. We can't forget about the big picture.
Yeah.
I'm curious, what are some of the specific technologies that are making all of this possible? It feels like we're on the verge of some serious breakthroughs.
Absolutely. And one of the biggest drivers of this progress is artificial intelligence
Okay.
and machine learning.
Right.
They're completely revolutionizing every stage of asteroid mining, from selecting targets to controlling those complex swarms of robots that we talked about.
Yeah, I can imagine AI being crucial for those autonomous robots, especially when it comes to navigating and making decisions on the fly.
Exactly. We're talking about algorithms that enable robots to analyze sensor data in real time, adapt to unexpected events, and even learn from their experiences and from each other.
It's like having a team of robotic explorers out there,
Yeah.
constantly getting smarter and more efficient.
Exactly.
It's mind-blowing to think about.
Yeah.
What about the actual tools and equipment these robots will use? The research mentions some pretty specialized tech is needed to work on asteroids,
Right.
given the microgravity and, the harsh conditions.
Oh, definitely. We're not talking about your average power drill here.
Right.
For one thing, everything needs to be lightweight and incredibly energy efficient,
Okay.
but also needs to be robust enough to handle the extreme temperatures, the radiation,
Right.
and the potential for micrometeoroid impacts.
So what kind of tools are we talking about specifically? What are the engineers working on?
Well, for excavation, you've got things like plasma cutters, which use superheated gas to slice through rock,
Okay.
and grinders for more precise shaping and smoothing.
Mm-hmm.
There are also concepts for using focused microwaves to heat and fracture rock, potentially a less energy-intensive method than traditional drilling.
It sounds like a blend of very futuristic technology and some pretty clever adaptations of existing tools.
Exactly. And then you have the anchoring systems,
Right.
which are crucial for keeping those robots stable while they work.
Yeah.
Some designs use harpoons or drills that dig into the asteroid's surface, while others utilize magnetic fields to cling to metallic asteroids.
Now, I have to ask about optical mining again.
Okay.
I'm still a little fuzzy on the details of how that works. You said it uses concentrated sunlight, but how do you actually capture and focus enough sunlight to vaporize rock?
That's a great question. Optical mining is all about harnessing the power of the sun,
Okay.
but on a massive scale. Essentially, it involves using large, lightweight mirrors.
Okay.
Imagine giant reflective sails to collect and concentrate sunlight onto a small area of the asteroid's surface.
So it's like using a magnifying glass to burn ants, but way more high-tech.
That's a pretty good analogy.
Okay.
The concentrated sunlight heats the surface to extremely high temperatures, causing the rock to vaporize, and then those vapors, which contain the valuable elements, are collected and processed.
That's incredible.
Yeah.
It seems like optical mining would be especially useful for extracting those volatile compounds we talked about earlier, like water ice.
You're absolutely right. Water ice has a relatively low boiling point,
Okay.
making it ideal for extraction using this method. And as we discussed, water is incredibly valuable in space for fuel,
Right.
life support, even radiation shielding.
Okay, one more. Did you know, before we move on,
Okay.
did you know that platinum is one of the most abundant elements in certain types of asteroids?
Wow.
And some researchers believe that a single platinum-rich asteroid could contain more platinum than has ever been mined on Earth.
It's staggering to think about, isn't it? And that brings us to another crucial aspect of asteroid mining,
Okay.
power generation.
Right.
All of these robots, extraction systems, and processing plants need a reliable source of energy to function.
Right. And we're talking about millions of miles from the sun.
Yeah.
Solar panels seem like the obvious choice, but I imagine they become less effective as we venture further out.
That's a key challenge. Solar panels are great for missions that are closer to the sun, but their efficiency drops significantly as we move out into the asteroid belt and beyond.
Right.
That's why researchers are exploring a range of alternative power sources.
Like what are some of the options that are on the table?
Well, one option is to use radioisotope thermoelectric generators, or RTGs.
Okay.
These devices use the heat generated by the radioactive decay of plutonium to produce electricity.
So it's like a miniature nuclear power plant.
In a way, yes.
Okay.
For each robot or mining platform,
Right.
RTGs are incredibly reliable and can provide power for decades.
Wow.
But they also have some drawbacks.
Yeah.
They're expensive to produce, and there are safety concerns associated with using radioactive materials in space.
That makes sense. What are some of the other options that are being explored?
Well, another possibility is to use nuclear fission reactors,
Okay.
which are much more powerful than RTGs.
Mm.
However, the technology for miniaturizing and safely operating nuclear reactors in space is still under development.
Right. It sounds like a high-risk, high-reward scenario.
Definitely.
Yeah.
And then there's the idea of beaming energy from Earth using lasers or microwaves.
Wow.
It's a very ambitious concept, but it could potentially provide a continuous and reliable source of power for asteroid mining operations.
That sounds incredible, but also incredibly challenging.
Yeah.
Imagine trying to aim a laser beam at a moving target millions of miles away.
It's a huge engineering feat, but it's something that researchers are actively working on.
Wow.
And the potential benefits are enormous. Imagine being able to power entire mining colonies without having to rely on bulky and potentially hazardous power sources in space.
It's truly mind-boggling.
Yeah.
Okay, let's shift gears back to ISRU for a moment.
Okay.
We talk about fuel production and construction materials,
Right.
but what about the other essential ingredient for human life? Oxygen.
Mm.
How do we ensure a breathable atmosphere for those future asteroid miners?
That's a crucial question, and thankfully, asteroids can provide a solution for that as well.
Okay.
As we discussed, many asteroids contain water ice,
Right.
and water, as you know, is made up of hydrogen and oxygen.
Right. So we can use electrolysis to split the water molecules and create oxygen.
Precisely, just like we do for rocket propellant.
Okay.
And once we have a source of oxygen, we can start thinking about creating closed-loop life support systems, where plants and algae can be used to recycle carbon dioxide and generate breathable air.
It's fascinating how all of these pieces start to fit together.
Yeah.
Robots, ISRU power generation, all working in concert to create a self-sustaining ecosystem in space.
It's a beautiful example of how seemingly disparate technologies can come together to solve complex challenges.
Absolutely. But it's not just about the technology itself.
Right.
We also need to think strategically about how we design our missions to maximize efficiency and minimize risks.
Yeah, that brings us back to mission optimization. We touched on this earlier, but I'd love to hear more about how AI is being used to optimize everything from asteroid selection to trajectory planning.
Okay.
AI is playing an increasingly important role in mission optimization.
Yeah.
For instance, AI algorithms can analyze vast amounts of data from telescopes and other sources to identify the most promising asteroid targets,
Okay.
those with the right combination of resources, size, and orbital characteristics.
So it's like having a super smart space prospector sifting through mountains of data
Exactly.
to find those golden nuggets in the asteroid belt.
Exactly. And once a target is selected,
Yeah.
AI can help to plot the most fuel-efficient trajectory, taking into account gravitational assists from planets and other factors.
So we're not just blasting off in a straight line. We're
Right.
using the gravity of planets to slingshot our spacecraft towards the target.
Precisely. And AI can adjust those trajectories in real time,
Wow.
responding to changing conditions or new information.
Yeah.
It's like having a super smart space navigator guiding our spacecraft through the solar system.
That's amazing.
Yeah.
But even with the best planning,
Right.
things can go wrong in space.
Absolutely.
How do we ensure that our missions are resilient and can handle unexpected events?
That's where concepts like modular mission architectures come in.
Okay.
Instead of designing spacecraft as these monolithic entities,
Right.
we're moving towards systems that are made up of interchangeable modules.
So it's like building with Lego blocks.
Exactly.
Okay.
You can swap out components, add new features, and adapt to changing mission requirements.
Modularity allows for easier upgrades, repairs, even repurposing of spacecraft.
Exactly.
It also allows for redundancy, meaning we can have backup systems in place in case something goes wrong.
Exactly.
Yeah.
It's all about being prepared for the unexpected in the unforgiving environment of space.
Absolutely. Speaking of unexpected, are there any other surprising or lesser-known technologies that are being explored for asteroid mining?
One that's particularly fascinating is the idea of using tethers. Yeah, imagine a long, thin cable extending from a spacecraft or an asteroid mining platform.
What would those be used for?
Tethers have a wide range of potential applications.
Okay.
They can be used to transfer momentum, which could be helpful for maneuvering around asteroids or even launching materials back to Earth.
So it's like a giant cosmic yo-yo.
In a way, yes. And some researchers believe that tethers could even be used to generate electricity
Really?
by interacting with the magnetic field of a planet or an asteroid.
Okay, now that's truly mind-blowing.
Yeah.
We've covered so much ground,
We have.
from spider robots to space tethers.
It's amazing.
It's clear that the field of asteroid mining is brimming with innovation and creativity.
Yeah.
But I'm also curious about the real-world missions that are putting all of this technology to the test. What are some examples of missions that are pushing the boundaries of what's possible?
Well, as we mentioned earlier, Hayabusa 2 and OSIRIS-REx were groundbreaking missions,
Right.
demonstrated the feasibility of asteroid sample return. But there are many other exciting missions on the horizon.
Like what are some missions that we should be keeping an eye on?
Well, NASA's Psyche mission is scheduled to launch soon.
Okay.
It's the first mission dedicated to studying a metallic asteroid,
Wow.
and it will use advanced instruments to analyze its composition and magnetic field.
So we'll get a close-up look at what could be a treasure trove of valuable metals in space.
Exactly. And the data from Psyche will be invaluable for future asteroid mining missions.
Right.
Then there's the European Space Agency's Hera mission,
Okay.
which is part of an international collaboration to test planetary defense techniques.
Planetary defense. So we're talking about protecting Earth from asteroid impacts.
Precisely, Hera will rendezvous with the Didymos binary asteroid system
Okay.
after NASA's DART spacecraft deliberately crashes into one of the asteroids.
It's like a real-life space action movie.
It sounds intense.
Yeah.
But what does this have to do with asteroid mining?
Right.
Well, Hera will study the aftermath of the impact, providing valuable data about the dynamics of asteroid systems
Mm-hmm.
and how we can potentially deflect hazardous asteroids.
Right.
And this knowledge is crucial for ensuring the safety of future mining operations.
It makes sense. We need to understand how to navigate and interact with these celestial bodies safely and responsibly.
Absolutely.
But we've covered so much ground already.
I know we have.
Maybe it's time for a quick break before we dive into the bigger picture.
Okay.
The challenges, the potential, and what it all means for the future of humanity.
Welcome back. We've journeyed from, robotic spiders on asteroids to potential platinum riches, and even touched on the idea of cosmic yo-yos.
Yeah, it's been quite a ride.
Asteroid mining is sounding more and more like science fiction becoming reality.
It really is a remarkable convergence of imagination and engineering. But as we venture into this new frontier,
Right?
we need to acknowledge the challenges that lie ahead.
Right. We talked about, the complexities of integrating all these technologies.
Yeah. The power generation, hurdles in deep space, and then the ethical considerations surrounding resource ownership and, environmental impact. It feels like there's a lot to unpack there.
There is, and one of the biggest challenges we face is ensuring that all of these intricate systems can work together harmoniously.
Right.
We need seamless integration between the robots,
Right.
the ISRU units, the power sources, the communication systems. Everything needs to function flawlessly, millions of miles from any repair shop.
It's a massive orchestration challenge,
Yeah.
almost like coordinating a ballet of robots and technology in the vastness of space.
Exactly, and that requires advanced software, robust AI systems,
Mhm.
and a deep understanding of how these technologies interact in the unique environment of space.
Right.
We need to account for factors like radiation micrometeoroid impacts and those extreme temperature swings that can wreak havoc on sensitive equipment.
And let's not forget about the power problem.
Right.
We discussed some potential solutions like RTGs and beaming energy,
Mm.
but each has its own set of hurdles. How do we ensure a sustainable and reliable energy supply for these ambitious ventures?
That's a question that keeps many brilliant minds busy.
I bet.
One promising avenue is to develop more efficient and lightweight solar technologies that can function even in the dimmer regions of the asteroid belt.
Okay.
Imagine flexible solar panels that can wrap around a spacecraft or even be deployed as giant reflective sails to capture the faintest glimmers of sunlight.
So it sounds like we need to think creatively about capturing and storing energy in space.
Absolutely. And that might involve tapping into the energy sources on the asteroids themselves.
Oh, okay.
Some researchers believe we could potentially harness geothermal energy from the internal heat of certain asteroids,
Wow.
or even utilize the kinetic energy of their rotation.
That's fascinating. It seems like every challenge in space inspires a new wave of innovation.
It really does. And as we push the boundaries of what's possible, we also need to grapple with the ethical and legal complexities of asteroid mining. Who has the right to extract these resources?
Yeah.
How do we ensure equitable access and prevent the exploitation of these celestial bodies for the benefit of a select few?
It's a reminder that space exploration isn't just about technological prowess.
Right.
It's about responsible stewardship of our cosmic neighborhood.
Precisely. And that includes protecting the environment of these asteroids
Right.
and preventing any unintended consequences from our mining activities. We need to carefully consider the potential for contamination, debris generation, and any disruption to the natural dynamics of these celestial bodies.
It sounds like we need a comprehensive set of guidelines and regulations for responsible asteroid mining,
Yes.
kind of like a space-based version of environmental protection laws.
Exactly. And those guidelines will need to be developed collaboratively, involving international organizations, governments, private companies,
Right.
and the scientific community. It's a global endeavor that requires a shared commitment to ethical and sustainable space exploration.
Absolutely. Okay, so we've talked about the challenges, but let's shift gears and talk about the incredible potential of asteroid mining.
Okay.
I think it's safe to say that the benefits could be truly transformative for humanity.
They absolutely could imagine a future where we're no longer limited by Earth's finite resources.
Right.
Asteroid mining could provide us with vast quantities of metals, water, and other material, enabling us to build incredible structures in space revolutionize our industries, and even expand our civilization beyond Earth.
It's like opening up a whole new chapter in human history.
Yeah.
A chapter where we become a multiplanetary species harnessing the resources of the solar system to solve our challenges and create a more sustainable future.
Exactly. Imagine constructing massive solar power stations in space,
Wow.
beaming clean energy back to Earth, potentially solving our energy crisis. We could build sprawling space habitats,
Yeah.
alleviating the pressures on our increasingly crowded planet. We could even use asteroid resources to fuel interstellar missions, venturing beyond our solar system and exploring the vast unknown.
It's mind-boggling to think about the possibilities.
It is.
But as we embark on this incredible journey, what's the key message we should leave our listener with?
Okay.
What's the most important thing to remember?
I think the most crucial takeaway is that asteroid mining is more than just a technological challenge. It's a societal one. It will require collaboration, innovation, a willingness to think differently, and a commitment to ethical and sustainable practices.
It's a call to action for all of us.
It is.
Scientists, engineers, policymakers, entrepreneurs, and citizens to work together to shape this exciting future responsibly and ensure that the benefits are shared by all of humanity.
Beautifully said. And as we venture further into the cosmos,
Yeah.
it's important to remember that we're not just extracting resources, we're expanding our knowledge, our capabilities, and our understanding of our place in the universe.
And perhaps as we delve deeper into the secrets held within these asteroids, we'll uncover even more profound insights into the origins of our solar system and the very building blocks of life itself.
It's a truly awe-inspiring thought.
Well, on that note, we'll wrap up our deep dive into the fascinating world of asteroid mining tech.
Yeah.
It's been an incredible journey, and we hope you've enjoyed exploring the challenges, the possibilities, and the sheer wonder of this emerging field.
And if your curiosity has been piqued and you'd like to delve even deeper, be sure to check out the suggested readings from your source material.
Yes, you'll find links to those resources in the show notes.
Great.
Thanks for joining us on this cosmic adventure. Until next time, keep looking up, keep exploring, and keep dreaming big. The future is out there waiting to be discovered.